Alright, welcome to the second half of section 2.1, power and radical functions. We talked about power functions or functions with exponents in the last video, and then now in this video we're going to talk about radical functions, functions that have radicals in it, okay, or square roots or cubed roots or fourth roots. Alright, so we're going to graph and analyze radical functions and solve radical equations. Alright, so we can recall, okay, and you have learned this before when we were doing exponent properties, that if you have an exponent of a fraction, p over n, okay, you can turn that into a radical. The bottom number is always whatever your radical is worth, and the top number is the exponent under the inside. So if you have, let's say, x to the 3/4, that's really, okay, turn into a square root. The bottom number is the radical worth, and the top number goes on your base. So, oops, if I put a 2, it's actually a 3. All right, so the fourth root of x cubed. So the bottom number goes on the square root, and the top number is the exponent on your base. Okay, so let's look at one more example. Y to the 5/6. That means the sixth root of y to the 5th. Okay. All right, so let's see here. A radical function is a function of the form where n and p are positive integers greater than 1 and have no common factors. Okay, so n and p are positive integers greater than 1. Okay, so we're not using 1 for either of these. Greater than 1, and they have no common factors. So if you look at here, 2 and 3 don't share factors, 3 and 4 don't share factors. Okay, so that's what that means, and that's what a radical function is. It's a function with a radical. It's as simple as that. Okay, so let's see what we got here. All right, so this is a little chart here that shows what radical functions look like. If your n is even, 2, 4, 6, 8, so far, your graph is going to look like this. Okay, why is that the case? Why isn't there anything on the negative side? Because if you have, for instance, a square root, you cannot have a negative number. Okay, that cannot work. So negatives are not possible when n is even. When n is odd, for instance, the fifth root of x, you can have negative numbers because you can take the fifth root. For instance, you can take the cubed root of -8 because the answer is -2. -2 times -2 times -2 is -8. Okay, so negative numbers do work for those. And what this chart shows you is all the different characteristics we've been talking about for the last 3 weeks. Domain, range, x-intercepts, y's, continuity, symmetry, maximums, end behavior, all those different things this chart talks about. So you can use this as a nice little reference. Okay, so we're going to graph a couple of these just like we did yesterday. So here's a radical function, 2 times the fourth root of 5x to the third. Okay, now we're going to use our table here. Now let's think about this. That 4 is even. Okay, so we do not have any x values that are negative. It's not possible. Okay, so I'm going to get rid of our negative values. We're not going to use those. Now we're not going to do this work ourselves. We're going to let the calculator do some of the work for us. All right. Now, this isn't very easy to type into the calculator, so I'm going to show you a nice little easier way to do this. So we're going to do 2 times 5x cubed to the 1/4, because the fourth root equals the 1/4 exponent. And I'm not going to put the 3 on top because this 3 only goes to the x. So this equation right here should give us on the calculator what the radical is. All right, so let's go to our calculator. I'm going to type in 2 times parentheses 5x cubed, close my parentheses. I'm going to raise that to the 1/4, so I'm going to do in parentheses 1 divided by 4. I could have done 0.25, but I'll just do 1/4. Okay, so let's graph it. Okay, notice that looks very similar to what we have here. All right, so let's go to our chart. I want to graph this by hand though. All right, so let's see here. So notice any negative number is giving us an error. Okay, anytime your n is even, like this one 4, okay, you can't get an answer. So all the negative numbers aren't going to work. So when we plug in 0, we get 0. So I'm going to go down here. When we plug in 0, we get 0. Okay, let's see what we get when we have 1. Okay, when we plug in 1, we get 2.99. Okay, 2.99. What do we get when we get 2? We plug in 2, we get 5.03. 5.03. 5.03. What do we get when we plug in 3? Okay, I go down 1. So if we plug in 3, we get 6.82. 6.82. 6.82. 4 is 8.46. 8.46. And 5, we go down 1. 5 is 10. Okay, 5 is 10. All right, so we're going to plot these on our grid here. So let's see. All right, so 0, 0, 1, 2.99, so really close to 3. 3, 1, 2, 3. Oops, 2, sorry. 2 is 5.03. 1, 2, 3, 4, 5, and a little bit more. 3, 6.82. It's close to 7. 4, 1, 2, 3, 4. I think this top line is 8, so it's 8.46, so it's about halfway. All right, and then I don't have to graph them all. Hopefully you can see the general shape of this graph. Hopefully you'd be able to find the domain, the range, okay, where it approaches infinity, negative infinity, things like that. Okay, so but that's how you graph these by hand and answer those questions. Okay, the questions can be answered pretty easily just by looking at the graph. You have this information. You guys know all of this stuff from chapter 1. All right, so now let's try one that is not even, but it is an odd. Okay, so negatives are going to work. So how am I going to type this in the calculator? It says 1/4. So I'm going to do 1/4. I said 1/4 and I wrote 1/2. So 1/4 times, I'm going to put in parentheses what's underneath the square root, so 6x minus 8, and I'm going to raise it to my power, which is 1/5. Okay, the fifth root is 1/5. All right, so I'm going to go to my calculator. Y equals, get rid of what's here. Instead of 1/4, I'm just going to do 0.25 times, put in parentheses 6x minus 8, parentheses, raised to the 1, oops, I need parentheses around fractions, 1 divided by 5. And I'm going to hit enter, I'm going to hit graph. Alright, so there's our curve. Doesn't look very nice in our picture, but we're interested in the table. Alright, so let's see here. So we start at -3. So -3 is 0.4797. 0.4797. -2 is 0.4551. Oops. 0.4551. -1 is -0.4238. -0.4238. 0 is -0.3789. -0.3789. 1, okay, 1, I get -0.2872. -0.2872. When I get 2, now it's positive, 0.32988. 0.32988. And what do I get when I get 3? Let's go down to 3. 3 is equal to 0.39622. 0.39622. All right, so let's graph this really quick. So -3, 1, 2, 3. Oops, these are all negatives. I forgot to put the negatives. -3, negative point, that's really close to 0.5, a little bit higher, okay, a little bit higher, 0 is negative, okay, it's really close, 1, even closer, this is getting really close, and all of a sudden we shoot to here, and a little bit higher. So this is a very weird graph because there's not much going on here. And you could keep going forever and ever and ever. All right, so that's that graph, and you should be able to answer all the questions, domain, range, things like that. So if you need to plug in a few more numbers, plug in a few more numbers to see what's happening. If this is going to go higher, if it's going to go lower, you can look at your chart. Okay, notice that these are keep getting bigger and bigger and bigger and bigger. The y values keep getting bigger, and so it's not really approaching any number. It's just keep getting higher and higher and higher. Okay, so that's how you graph radical functions. All right, so now what do we do when we have radical equations? This is just basic algebra stuff. Okay, so my goal is to get x by itself. All right, so now the problem is I have to get rid of this square root in order to get to this x. All right, so I'm going to add 2 first. Add 2. 2's go away. I'm left with 2x plus 2 is equal to the square root of 100 minus 12x. All right. Now I can get rid of my square root. So how do I get rid of a square root? Okay, square. Square the left. Power of 2, square root go away. I'm left with 100 minus 12x is equal to. Now this says 2x plus 2 squared, so I have to FOIL 2x plus 2 twice. All right, so let's FOIL and put my answer down here. So 2x times 2x is 4x squared. 2x times 2 is 4x. And I have another 2 times 2x, so I really have 8x. And then I have a 2 times a 2, which is 4. All right. So now what we need to do is we need to get everything on the left-hand side. Okay. So 4x squared is alone. I'm going to add 12x, add 12x. So we've gone over here. 8x plus 12x is 20x. So this is gone, this is gone, this is gone. And then I have positive 4. Okay, I'm going to subtract 100. So what do I have here? I have minus 100. So I have negative 96 is equal to 0. All right. So I have 4x squared plus 20x minus 96 is equal to 0. Oops. All right, sorry for that pause. All right, so so what we basically have to do is we have to figure out how can we get these x's by itself. Okay, so I'm going to factor. And if you notice, a 4, a 20, 96, they're all divisible by 4. So I'm going to factor out a 4 out of this whole problem and see what I have left over. 4 divided by 4 is 1, so I have x squared left over. 20 divided by 4 is 5 with an x left over. Minus 96 divided by 4 is 24. All right. So now I have a general quadratic equation. I should be able to factor this into two binomials. So x times x is x squared. What two numbers, now we always talk about this in class, what two numbers multiply to be negative 24 and add to be positive 5? Okay, so let's think about this. So how do we get 24? 6 times 4, one's got to be negative, negative 6, positive 4, positive 8, negative 3, negative 8, positive 3. Do any of these numbers add to positive 5? Okay, hopefully you can see that this one does right here. So plus 8 and negative 3. All right, so we factored it. It's fully factored. We should be able to write our answers now. Okay, please remember from Algebra 2, you always take the opposites. So if this set this equal to 0, you get negative 8. And if you set this one equal to 0, you get positive 3. So our two answers for this problem are negative 8 and positive 3. That's a tough problem. We'll do more of these examples. All right, so we have another one right here. Okay, you can try this. Okay, we're going to do it, we'll do it in class, but I want to make sure that we kind of know how to do these before we move on. So try this one, see if you can get the correct answer. We'll go over it tomorrow. Please remind me. Have a good night. I will see you in class.